This is Tutorial 6A Question 0A, Part C. We are now asked to show that the columns of PK are orthogonal to each other, and hence the inverse matrix can be easily found. Basically, it is to say, generate these column vectors and perform dot product of this vector to this vector, and you realize that it will be 0. This vector to this vector will also be 0. This vector B1 to B2 is 0, so on and so forth. The columns of these vectors are orthogonal to each other. We'll use the W matrix to demonstrate this. The W matrix are also formed very much like columns of B. The only difference is that now the vectors are conjugates of B's. So this is actually B0, this is B1 conjugate, this is B2 conjugate. And why is this so? It's because the elements of this W to the power of the values have a negative here. And then you will see that the phases, instead of rotating anti-clockwise like previously, they are now rotating clockwise. Other than that, this W matrix and the matrix that we have studied so far were the same. Now, the columns of these are orthogonal to each other. Why is this so? I will suggest you to look at this search proof that the DTFT matrix is unitary. And this is the matrix that we have seen. And the proof is simply here. Open up the W with multiply W with W star with W to show that it is the identity. What is W star? W star is the complex conjugate of W. Basically, it allows us to very quickly perform the row of this matrix multiplied by the column of the other matrix. And we'll see that when we multiply this row by the other guy's column, we are trying to find the relationship between this row and all the other columns. And you will see that the answer is that only the diagonal entries have values. In this case is I, because the W is weighted by 1 over root n. And all the off elements of the diagonals are 0, showing that the columns of W are orthogonal to each other. The proof is here. Simply we use the geometric series to show that the off-diagonal elements will sum to 0. In my own answer, it is not a proof. I simply write a MATLAB program to generate the W matrix, the W prime, which is a complex conjugate of it, and multiply. And you will see that only the diagonal elements is, in this example, 4, is because we didn't do 1 over root 4 to normalize the matrix. But only the diagonal elements have values and the off-diagonal elements are 0. So W times W prime, or W times W star, and W star times W are the weighted identity of 4. Now, such matrix that is inverse as complex conjugate, the name is called unitary matrix. So the W matrix is a unitary matrix. Thank you.